In this video, we're going to look at the problems on page 9 of chapter 2, section 3. And these are going to involve some systems of equations that are a little bit different. In this system, we've got 3 equations, but only 2 variables. We can still turn it into an augmented matrix the same way. 1, 2, 4, 1, negative 2, 0, and 4, 3, 12. No problem. Okay, so the first thing we're going to do is subtract off row 1 multiple times to get rid of our 1 and our 4 in the first column. So that is, we'll get row 2 minus row 1 and row 3 minus 4 row 1. This winds up with the matrix 1, 2, 4. Row 1 doesn't change. 0, negative 4, negative 4, and 0, negative 5, negative 4. There we go. Next, we will divide row 2 by negative 4. So we got negative 1/4 row 2. Which gives us 1, 2, 4, still doesn't change. 0, 1, 1, 0, negative 5, negative 4. Finally, we're going to add 5 row 2 to row 3. Which gives us 1. Oh, and we're going to subtract 2 row 2 from row 1 as well, because we can. We don't need to do that because just doing the other thing would be easier in showing us where we're going, but we're going to do it anyway. So we get 1, 0, 3. Sorry, 1, 0, 1, 0, 2, because we got to subtract 2 row 2. 0, 1, 1, no problem. And now 0, 0, 1. And there we have a problem because we have 0x plus 0y equals 1, which means 0 equals 1, and thus reality breaks. 0 does not equal 1, so there are no solutions. Moving on. Here we have an equation that has more variables than it has equations. We can still set up our matrix. 1, 2, negative 3, 1, negative 2. 3, negative 1, negative 2, negative 4, 1, 2, 3, negative 5, 1, negative 3. Well, the first thing we want to do now is pivot around that 1. So we're going to subtract 3 row 1 from row 2 and 2 row 1 from row 3. This gives us the matrix 1, 2, negative 3, 1, negative 2, 0, negative 7, 7, negative 7, 7, 0, negative 1, 1, negative 1, 1. Having done that, now we want to take our second row and divide it by negative 7. Negative 1/7 row 2 results in 1, 2, negative 3, 1, negative 2, 0, 1, negative 1, 1, negative 1, 0, negative 1, 1, negative 1, 1. Okay, so in our last step, we'll take row 1 minus 2 row 2 and row 3 plus row 2. Which gives us our final matrix, 1, 0, -1, -1, 0, 0, 1, -1, 1, -1, 0, 0, 0, 0, 0. This gives us a couple of equations that define this. X minus z minus w equals 0, and y minus z plus w equals -1. Well, if we change some things around here and rewrite and say, pick two numbers, s and t, and we're going to let those stand for z and w. Then we can rewrite these equations into forms that give us a little more detail. If we pick any two values, s and t, then x equals s plus t, y equals s minus t minus 1, z equals s, and w equals t. So we can easily find solutions to the system of these four values. That's all for this one. If you have any questions, let me know.